day, learners. Welcome to our general mathematics tutorial. Our lesson for today is simple and compound propositions. So, what is a proposition? In mathematics, a proposition is a declarative statement that is either true or false, but not both. Propositions are used in logic to form a statement, arguments, or any proofs. They can be classified as simple or compound. This lesson is somehow the same as the simple and compound proposition is the subject English. However, this lesson in math will more likely to lack or tackle focus on mathematical statements rather than just simple statements or sentences. What are the importance of propositions in mathematics? The importance of propositions in mathematics are the following. So first, truth value. Every proposition must have a truth value, either true or false. Second, building logical arguments. Propositions are the foundation of logical reasoning and mathematical proofs. Lastly, applications in logic. They help in defining logical operations, evaluating statements, and constructing valid arguments. So, understanding propositions and logical connectors. First, truth value, the basis of propositions. Every proposition must have a truth value. It is either true or false, and nothing in between. This binary nature of propositions is what logical reasoning to function consistently. Think of it this way. If I say, the sun rises in the east, you can clearly determine that the statement is true. On the other hand, if I say the moon is made of cheese, you can confidently determine that this statement is false. There is no room for ambiguity. This clarity is crucial in both mathematics and logics, where each statement forms the foundation for building larger arguments and solving complex questions. Second, simple propositions or atomic propositions. Simple propositions, also known as the atomic propositions, are statements that expresses a single idea or fact. They cannot be broken down further into smaller components. Each simple proposition can stand on its own and have a true value. Examples of propositions. First is a 7 is a prime number. This is true because 7 only be divided by 1 and itself without leaving a remainder. The second one is 4 plus 5 equals 9. This is true because mathematically the addition is correct. The triangle has 3 sides. This is true because it is defining a property of triangles. Each of these examples is complete and independent. You don't need additional information to determine whether they are true or false. Third is the compound proposition. So, first is the and, or also known as the conjunction. A conjunction combines two statements using the word add for the compound propositions to be true. Both individual propositions must be true. The symbol is. So let's go to examples. The first proposition is 7 is a prime number. The second proposition is 4 plus 5 equals 9. So the combined is 7 is a prime number and 4 plus 5 equals 9. So the result is true because both parts are true. So the key rule is if either proposition is false, the entire statement becomes false. Example, 7 is a prime number and 4 plus 5 equals 10. Here, the second part is false, so the entire statement is false. So let's go to the second one. Or also known as the disjunction. A disjunction joins two propositions with the word or. The compound propositions is true if at least one of the proposition is true. The symbol is. So let's go to examples. The first proposition is 2 plus 2 equals 4. And the second proposition is 5 is an odd number. So when combined, 2 plus 2 equals 4, or 5 is just an odd number. True, so the result is true, because at least one, in the case both of the proposition is true. The key rule is a disjunction is false, only when both propositions are false. Example, 2 plus 2 equals 5, or 5 is an even number. Both parts are false, so the statement is false. So let's go to the third one, not, or also known as negation. Negation flips the true value of single propositions. It essentially states that the opposite of a given proposition is true. The symbol is, example, the original is 2 plus 2 equals 5, so it's false. So the negated one is, it is not true that 2 plus 2 equals 5. The key rule, if the original statement is true, the negated version will be false, and the vice versa. Example, the original one, the earth is round. It is true. The negated one is, the earth is not round. It is false. So let's go to the fourth one. If that, or also known as implication. An implication connects two propositions in a conditional format. If P then Q, the truth of the statement is said to depend on the truth of the other. Simple. Example, if P3 is a prime number, then Q9 is divisible by 3. Combined, if 3 is a prime number, then 9 is divisible by 3. So the result is true. Key rule, an implication is false only when the proposition is true and the second is false. Example, if P3 is a prime number, true, then Q9 is not divisible by 3, so it's false. Combine, if 3 is a prime number, the 9 is not divisible by 3, it is false. So the last, if and only if, or also known as biconditional. A biconditional states that two propositions are equivalent. One is true if and only if the other one is true. It continues a conditional statement and it's converse. The symbol is. So let's go to examples. Proposition 1. A figure is a square. Proposition 2. It has 4 equal sides and 4 right angles. Combine, a figure is a square if and only if it has 4 sides and 4 right angles. The result is true because the two propositions define each other. Key rule, both propositions and must have the same truth value. Either both are true or both are false. Example, the number is even. It is divided by 2. True, because being even and divisible by 2 are equivalent. So, let's go to conclusion. Understanding propositions and logical connectives gives us the tools to construct, analyze, and evaluate arguments in a structured way, whether it is simple facts or complex conditional statements. Logical reasoning is all about clarity and precision. By mastering 3 basics, you can approach any logical mathematical problem with confidence. So now, let's dive into the other examples of simple propositions and compound propositions. So let's go with the first one. 2 plus 3 is equals 5. The truth value is true. The explanation is, this is a true statement because the sum of 2 and 3 equals 5. No calculation needed. This is a simple and a factual statement. So the second one is, the square root of 16 is 4. Truth value is still true. The explanation is, this is true because the square root of 16 is indeed 4. This is a straightforward mathematical fact. So the third one is, 5 is an even number. The truth value is false. Explanation, this statement is false because 5 is an odd number, not even. Fourth is, for real numbers x squared is greater than or equal to 0. The truth value is true. Explanation, this is true because the square of any real number is always non-negative. Whether the number is positive or negative, squaring it results in a positive number or 0. So the last one in simple proposition is, there are 10 sides in a triangle. So the truth value is false. The explanation is, this is false because a triangle always has 3 sides. A statement claiming there are 10 sides in a triangle is incorrect. So let's dive into compound propositions. Now that we've covered simple propositions, let's move on to compound propositions. These are formed by combining 2 or more simple propositions using logical connectives. Let's break down into different types of logical connectives and look at examples for each. So first one is conjunction or and. A conjunction is true if both parts of the statements are true. Symbol is, and it is read as and. So example 1, if x equals 4, then x squared equals 16 and x is an even number. The truth value is true. The explanation is, both parts are true when x equals 4. The square of 4 is 16 and 4 is indeed an even number. The next one is disjunction or. A disjunction is true if at least one part of the statement is true. Symbol is, and it is read as or. The example 1. Or the next one, x equals 3 or x equals 5. Truth value is true. The explanation is, the statement is true if x is either 3 or 5. As soon as one of the conditions is satisfied, the entire statement is true. So the next one is conditional or if then. A conditional statement is true unless first part is true and the second part is false. Symbol is, and it is read as implies. Example 1. If x equals 2, then x squared equals 4. Truth value is true, and the explanation is, this is true because when x equals 2, squaring 2 gives us 4, which is correct. So the next one is biconditional. It is called as if and only if. A biconditional is true if both parts are either true or false together. Symbol is, and it is read as if and only if. So the example is x equals 4 if and only if x squared is equals to 16. Truth value is true. Explanation. The explanation is, this is true because x equals 4 implies x squared equals 16 and x squared equals 16 implies x equals 4. Both parts are true together. So the last one is negation, or it is read as not. Negation reverses the truth value of a statement. If the original statement is true, the negation will be false. And if the original statement is false, the negation will be true. The symbol is. So let's go to the example. It is not true that 3 plus 2 is equals to 8. The truth value is true. The explanation is, the original statement 3 plus 2 equals 8 is false. So the negation reverses it, making the new statement true. So let's go to the conclusion. We've now explored a range of logical propositions, from simple statements to complex compound propositions using logical connectives. Whether we are using conjunctions, disjunctions, conditionals, biconditionals, or negations, these logical tools help us form clear and valid arguments. Understanding how these connectives works allows us to construct and evaluate more complex statements in mathematics and logic. Now that we fully understand simple and compound propositions, let's tackle the truth table. Number one, the simple proposition. A simple proposition is a single statement like P, which can be either true or false. Number two, compound proposition. A compound proposition combines two or more simple propositions using logical connectives such as and, or, implies, and biconditional.
So, here are examples with a truth table for different logical connectives. First, and. For example, P and Q. Both must be true for the results to be true. The second one, or. For example, P or Q. True if at least one of P or Q is true. Third one, not. For example, not P inverts the truth value of P. Fourth one implies, for example, if P then Q. False only when P is true and Q is false. Last one, biconditional. For example, P if and only if Q. True when P and Q have the same truth value.